right. Get this show going. If you're watching this after the fact, make sure you check the description below for time codes so that you can skip around. These streams tend to be about 2 hours long, so the time codes are great. Thank you to David in advance for making those so that people can find their way around the video. We'll just take a few minutes here for people to collect, and I'll say hello to folks, and then we'll be on our way. Oh, let me pause these. I have like 2 tabs that play it back to me. Ha! And I paused it in a really weird, when I'm making a weird face. Of course. Yeah, and both cats are in the window right now. Enjoying the sun. Hello, Pierre. Deep dive into USB. Hello, Unexpected Maker. Hello, David. Hello, William. Hi, Neil. Hello, Michael. Hello, Beata. And Be Alone 20. Hello. Oh, and I don't have the Discord's on the wrong thing. This is the third to last stream I'm going to do before I'm off on paternity leave. Hello, Thomas. Hello, foamyguy. Yeah, we'll see if Vin wants to say. Vin is the closer of the 2 cats. She's the one that usually doesn't like it when I'm talking, but nobody's in the house besides me, so that I'm the only human she can hang out with right now. Hey, Deshipu. Hello, Mark. All right, I guess I don't have to keep waiting. We'll collect some more people. Hey, Keith EE. So we'll do some housekeeping and then go from there. Thanks, Neil. Yeah, I'm very excited. We have just over, it's a month and a week until the due date, so. Is that your cats? Yep, these are the 2 kitties. Spook is the one under the plants further away, and then Vin is there with just the spot on her head. Hi, Hamslab. Hello, Anecdata. Hello, Folknology. Yep, everything's good. My partner's mom is in town, so that's been fun. Okay, so hello, everyone. Let me switch off cats, actually, before I do that. Hello, everyone. My name is Scott, and I work on CircuitPython for Adafruit. CircuitPython is a version of Python designed for microcontrollers, which are little inexpensive computers that are, yeah, really expensive, not super powerful, but they can go in a lot of different places, which is really cool. And yeah, so Adafruit pays me to work on CircuitPython and pays me to stream. Adafruit is an open source hardware and software company based out in New York City. So I work from home here with the kitties at my side. They're my coworkers from Seattle here. So yeah. Yeah, they're from the same, they're brother and sister from the same litter. So yeah, they're definitely related. If you want to support me, you can support me by supporting Adafruit by going to adafruit.com and purchasing hardware there. There's lots of cool stuff coming and lots of cool stuff already out if you're new to the world of hardware and software and embedded stuff. If you'd like to chat with the folks that are in here, this middle box, point that way. This middle box is the Discord server, which is a chat server that lasts throughout time, not just tied to individual streams. So you can go to the URL adafru.it/discord, and that will get you into the Discord server where I hang out. We do a bunch of CircuitPython development and a lot of helpful folks there. So it's a great place to go. I always point people to that. So This is a deep dive. It happens every week, normally on Fridays at 2 p.m. Pacific, which is basically now, 4 minutes past now. We typically go for about 2 hours. Things that are kind of further than that or longer than that are kind of exhausting, and folks usually set aside these 2 hours anyway. So because we have so much time, I'm happy to answer questions, which I'll get to in just a sec. I know I'm a little behind on the chat. But before I do that, the last few bits of housekeeping. Next week will also be on Friday, and the week after that, I think, as well. Those will be my last 2 streams before I go on paternity leave. The baby's not due until the end of next month, but I don't want to try to plan it and then have the baby come early and be worried about that. Plus, my wife is going to be off work starting next week, so it doesn't make sense for me to carry on being super rigorous while she's not working either. So 2 more after this one, and then foamyguy will continue doing deep dives in this time slot, which is awesome. So if you do want to find, if you do want to hang out with this crew at this time, we're going to have somebody else streaming, and foamyguy does great streams and lots of different CircuitPython related content. So thank you, foamyguy, for doing that. I really appreciate it. And I'll read off a bit of an update after that. But lastly, in the housekeeping section here, David DCD is very kind and takes notes during these streams. And that gives you time codes and little blurbs about what we're talking about when. So those have been collated by Patrick, Ask Patrick W. And they're on GitHub at github.com/adafruit/deep-dive-notes. So thank you to them both for putting those together. Okay. Let me catch up on the chat. If folks have questions, I'm happy to answer them, but generally technical questions are better than personal questions. But I'm a pretty open book as well. So Neil says, congrats, thank you. Third to last unless some happy surprises come early. Yep. These are my cats. Hello, Paul. And hello, Pierre. Yeah, I rearranged the furniture. So the thing against the window is actually like a bassinet stand, and I was thinking about putting it in here and then kind of decided against it. So I switched it up. I thought that would be fun. Hello, Joe. And I already answered Unexpected Maker's questions about the cats being siblings, which they are. And I think there was another pair from their litter that was also up for adoption, but these two both have smudges on their nose, which is makes it pretty hard to tell them apart, but you have to look at their ears to tell who's who. Andy Lear says, congrats, thank you. Be Alone says, how old are you? I'm in my mid-30s. I'll tell you that much. And hello, Randall. Thanks for joining. So that's the YouTube chat. Hello, I think I said hello to Bruce. I didn't say hi to you. Hamslab asked, any clues as to what foamyguy is going to do on Fridays after you're gone? And foamyguy is in the chat and said, I will continue on with deep dives on Fridays. Very similar type of content, working on CircuitPython related things. But it'll likely will spend more time in Python land than C land, and maybe some working on projects instead of core/libraries. I've been streaming Saturday mornings for a little while now. You can check those out on YouTube. If you want a sneak peek, you can check out one of those prior streams. And the deep dives will end up being pretty similar. And hello, Bruce, again. So that's it. Thanks again to foamyguy for being game to step into this time slot. I don't know what my plans are, whether I'll come back to it or whatever. This is my first kid, so I don't know what to expect, and I don't know what I'm going to want to do, and I don't know where Adafruit's going to be by the time that I'm kind of back into full swing. So we'll play it by ear. I'll let you know. But foamyguy does awesome streams too, so maybe I'll just hop in the chats on those to start. Okay, any questions before I kind of make stuff up as I go along, which is what I do every week? And I know there's a lag, so I'll just delay a little bit. Any CircuitPython or hardware questions topics you want to cover before we get going? I don't see any. All right, cool. Well, I can make stuff up. So I think last week I started to talk about that I was looking at USB host. The BLE stuff that I had gotten in is all checked in now, I think. So I've like turned that page. I'm realizing as I get closer and closer to this baby coming that the larger projects are being harder and harder for me to focus on. So before I get into the USB host stuff, I think I should actually, there's just a couple of fixes that could be mildly interesting for me to cover. So Dan and I were talking about doing a 7.2 release, and Jeff too. So we went through all the issues and we categorized them. Ooh, Pierre has a related question. Let me finish my thought on 7.2 and then I'll do that. Do I know anything about phones? Not a lot about phones. Embedded electronics are simpler than phones generally. So yeah, we're trying to get 7.2 done. We had done the milestones earlier in the week, and then there was like 3 or 4 issues left. And so yesterday I was like, hey Dan, do you want me to pick up a couple of these? So let me just briefly go to the desktop and just talk through the couple that I did. And it was quite nice to get something simple and knock it out. So Dan updated the frozen libraries after realizing that IR remote was fixed. I switched this thing so that we changed the default state of pins on the ESP port. And so Dan had noticed that on the mag tag, the speaker was clicking because the speaker's on when it's high. And so there was this this noise that was caused by us turning on the speaker. So I introduced a thing in the espressive port that allows you a board individually to override what a pin reset means. So on espressive, you can say, if you define espressive board reset pin number, it'll give you a pin number and then you can check it. And if you want to reset it, you reset it and then return true. And then after that, it will be ignored after that. So that was one of the things I did. And then Neradoc did a fix, so thank you, Neradoc. And then there was this crash on espressive when setting RGB brightness to 0. And both Dan and I created pull requests like one after another. And we decided to go with the way that I had fixed it. So the fix that I had was, the issue was that it was trying to transmit over the SPI device when the SPI device wasn't initialized. Because we used to have, pre 7.0, the status LED would be active throughout, like before user code was run, as user code was running, and after. And there was like this weird handoff logic. And in 7.0, we simplified it where the CircuitPython only uses the status LED before and after user code is run. And so this was a crash due to the fact that we had this thing here. So if you set the status brightness, it tried to retransmit the last color with the brightness adjusted. But that doesn't work because that crashes now because the user code, when the user code to set the brightness, whether it's in code.py or in the REPL, like either way, the status LED pixel is not on. So it ends up potentially crashing. So I documented it a little bit too to make sure that it was like, hey, when you set the status RGB brightness, it's going to take effect next time that it's actually used. It's not going to happen immediately. So I knocked those two out. Is there anything else interesting? Oh, this is going to be interesting, and Unexpected Maker might be interested in this, is Dan fixed this issue with how we handle deep sleep in CircuitPython. When Dan implemented it, we were concerned. He was concerned about the ability to actually like plug in USB and be able to edit the code. But the problem is that USB enumeration, which is the process, and this is kind of dovetailing into USB, so maybe we should just go there. Once you plug something in, there's a process called enumeration, which is how you get like a device assigned an address and then figure out kind of what kind of device it is, and that takes time. And so with deep sleep, and if we wanted you to be able to plug in a device and have it pop up as CircuitPy, even when it's deep sleeping, we actually had to delay like 5 seconds before to give it time to decide whether we actually wanted to stay awake, so that we could do the USB stuff. And I thought when we had implemented it that we had talked about a policy where the very first time CircuitPython starts up, it will do that 5-minute wait, or 5-second wait, not 5 minutes, 5-second wait, to give USB a time to turn on. But then if it was waking up from a deep sleep, we wouldn't do that wait. So this is what Dan implemented. So this will be in 7.2. So the idea is that if you hit the reset button or you plug it in, it'll wait the 5 seconds to make sure it will wait 5 seconds before deep sleeping to make sure that you didn't want to connect to CircuitPy like it's connected over USB. But then if that 5 seconds goes by and it goes to deep sleep, the next time it wakes up, it's not going to wait that 5 seconds. It's going to run the code as fast as it can and then go back to sleep. And this should be good for anybody who's doing lower power stuff in CircuitPython, is that a lot of the power that you consume is actually in that period where like CircuitPython is running. So by shortening that to not 5 seconds, it should actually improve battery life a lot, which I'm very excited about. So thanks to Dan for fixing that. So the moral of the story is low power stuff should get better. That's across, I think this is universal. It was in main.py. So any port that does deep sleep should see improvements. But then the caveat is that if you do want to actually be able to connect to something over USB, you'll have to hit reset. Deep sleep won't give USB enough time to enumerate otherwise. Okay, I don't think. Oh, Purple's fixed the pressing the any key responding slowly on espressive, which was they saw me struggle with on the stream, so it was awesome that they found and fixed that. So thank you, Purples, for that. Is there a way we can hook into that? I have VBUS sense on my S3 board, so I can bypass that as not VBUS present. We don't currently have a way, but you could totally add it. I would suggest starting from this PR, because it will show you exactly where that mechanic is happening. So it's 6051 is the PR that changes it. So yeah, take a look at that. Hey, Charles. But yeah, we don't currently have a way to hook it to the board to know. And I'm not actually sure you want it on VBUS either, because it's possible you're using like a USB charge only cable, well, I guess, yeah, it's not clear to me whether you actually want that or not. If you just know you have VBUS. Pierre says that's a great improvement. What about if I want BLE after sleeping? Sending a message saying this is how hot I am over BLE. So this also should take into account the BLE workflow stuff. But the expectation, I think, is that if you want to wake up every so often to do a BLE broadcast, for example, then you need to you just wake up and do it and then go back to sleep. There is a register you can check to see if VUSB is on, perhaps other boards too. Yeah, we don't take that into account. We're doing it based on enumeration, I think. I think it's dependent on TinyUSB at the moment. Okay, I think, yeah, Jeff improved git describe, and we'll test that because we're about to branch. We're about to branch 7.2. So we'll have a separate branch for 7.2, which will be our next stable release. And then Jeff's been working on merging in MicroPython 1.18. So that's all ready to go. We're just waiting to do the branch, and then we'll do the merge into 1.18. So we'll actually have like a 7.3 alpha with the new MicroPython stuff in shortly as well. Which is another reason we kind of liked it. Like that's kind of sometimes our forcing function for getting a stable release is we want to be able to have the pre-release builds be less stable because we have something that's like bigger that we're going to move in. And speaking of this, Jeff's in the chat and says the new performance stuff for MicroPython, the fast path and the lookup cache, which is one of the major features of MicroPython 1.18, gives a 19% performance boost in the most contrived example I could come up with compared to 7.2 Alpha 2. It's a loop that just accesses a member of an object. More details in my latest comment on the 1.18 merge PR. Correct. Pierre asked, the new MicroPython will be in 7.3. Yeah, that's our plan. If a MicroPython merge changes the MPY version, that forces us to do a major version, but this one does not. The next one will. So 1.19 will probably lead to 8.0, CircuitPython 8.0. I think those are the highlights. Merge Reanimator has been doing a lot of STM fixes, so that's been great. And we do actually have, there's a SAMD deep sleep fix that's almost ready to be merged in as well. And then the merge PR is 6038. And Jeff didn't turn on the performance stuff. I was like, hey, could you just take a little bit? I think it's like kind of impressive. So a little loop on the RP2040 became nearly 20% faster. So yeah, subscribe to that PR 6038. Should be coming in shortly. And then we won't be able to do a 7.3 release officially until 7.2 is stable, but I think 7.2 has generally been pretty good. So my guess would be that 7.2 will be stable in the next week or two. Charles is saying, oh, I should say thank you to Jeff for doing the merge. Merges are not always pleasant, so thank you for doing that. And thank you, of course, to all of the MicroPython contributors for making MicroPython even better. Okay, Charles says, I need USB host so I can build a MIDI concentrator that will allow more than one USB device to be connected through one port. Yeah, so let's talk USB. And if folks have questions, feel free to ask them. And in fact, did I miss one from Pierre? So Pierre's question about USB host is that says, is that mostly a traditional, in quotes, Raspberry Pi thing, or some microcontrollers also support it? I know you need hardware for it. Jeff says, sometimes I like a week where it's almost all code and no hardware. I know what you mean. Sometimes getting new hardware set up is like a hurdle that I've got to get myself over. So I think, yes, USB host tends to be more of a like full computer sort of thing. But at the same time, a lot of them do actually support it. So the thing that you want to look for generally is in microcontrollers, it will be OTG. So if it's USB-OTG, OTG stands for on the go, and it's a way of detecting whether the USB should be a device, which is what CircuitPython currently is, or a host. And I think generally, if it has native USB, it can be both. There's actually not a ton of difference between the two. It's more about, like, one of the trickier bits is like who provides the power. And yeah, so Randall says, what would you think of a port to x86 for retro computing? If somebody wanted to do it, it should work. Like, we already have a Unix port. I think one of the challenges, if you're talking bare metal, is just like the documentation, but I'm sure lots of people understand it. I just don't. I'm still getting into the Cortex-A Lambda stuff. Well, let's see. We can just use the NRF52840 as an example. The bigger challenge is, like, because CircuitPython kind of has that role as a USB device, and a lot of the boards only have one USB peripheral. It's not really like where USB host is interesting. The reason that this came up was more around the person who did the demo for the Raspberry Pi. For the Raspberry Pi Pico, the RP2040, being able to do USB host from a PIO, which is basically giving you a second native USB. That's more interesting, so that you could still do CircuitPy device, but at the same time you could also do USB host, which would be neat. So let's just see. It says USB 2.0, which is not telling us enough. But if we keep looking, how do I find the datasheet? Get started, development kit. Oh, here's the product brief. I remember how old x86 had BASIC built in. Would be cool to see the REPL instead. So CircuitPython and MicroPython are very 32-bit geared still. So you'd still want a 32-bit CPU, because that's kind of what it assumes. And remember, you need like 32K RAM or more. Where the heck? Why is it so hard to find the... Oh, it downloaded. Find the datasheet. So let's see what it says in terms of USB. Full speed USB controller. It doesn't say. Yeah, none of this tells you. I think we'll have to find the datasheet. Slitzer says, when will Adafruit stock more Raspberry Pi 4s? And the answer is when they receive more Raspberry Pi 4s from the Raspberry Pi folks. Oh, here's a documentation button. I saw a PIO ASM demo the other day in MicroPython. Was CircuitPython the origin of PIO ASM? I don't know what demo you're referring to, but the format for PIO ASM originates from the C. Hello, Kernel Panic. I like your name. The C version of the Pico SDK has a form of PIO ASM, and then it was my choice to basically write an assembler in CircuitPython to basically convert that standard syntax that they had documented in the datasheet and stuff, and then convert that into the bytes that are the actual assembly. Whereas MicroPython's approach was different originally. Like, Damien used lots of Python tricks to do Python that generates the same stuff. So we chose to do different approaches for that. I'm asking about nRF52. Some people do ask to make dongles for their fancy wired keyboards, make them wireless. Yeah, let's keep digging. Product specification. I have the older version. And let's open it. Oh. And so we're going to go, it's probably not core components, peripherals, alphabetical. So this explicitly here calls it USB device. So that's telling us that it doesn't do host. I think Nordic designed this own USB device themselves, so, or the USB peripheral, so it's unable to do it. Yeah, so this is just a thing. Yeah, so it doesn't look like the nRF52840 can do it. I'm a little curious because they now have the 5340. I know that's like the next gen. Can I click it? I can. So it says USB again. Let's go to documentation. SAMD21 can do it. I know that. Neradoc says USB host and Bluetooth workflow would have been a good combo. So the S3 can do OTG, I think. I'm not sure if Tiny USB does it. The USB supports it, but the S3 is probably that Bluetooth plus USB host combo that you're looking for. 5340 product spec, which we don't actually support this in CircuitPython yet, but I'm curious to see if they added it in the new gen. So let's do the same thing. Let's look for network core peripherals. And USB. So it's still just USB device in the 5340 as well. Michael says Tiny USB doesn't support it yet. Doesn't support USB host on the S3, right? But I think that the hardware does. I know I have the data sheet around here somewhere. Technical reference, that might actually tell us more. Preliminary. Yeah, so this says USB on the go. So that means that it can do both. Oh, Michael confirms both the S3 and the S2 can do OTG. Thank you, Michael. That's helpful. So yeah, so if you want BLE and USB, then the S3 is your your best option, I think. So this is, let's see. The S3 features USB on the go, along with an integrated transceiver. It can either operate as a host or a device and supports 12 megabits per second full speed and 1.5 megabit second low speed data rates of the USB 1.1 spec. the host negotiation protocol and the session request protocol are also supported. So that's a way for the two devices on each end to actually negotiate who's the host and who's the device. Okay. Device mode features. So today I wanted to talk more about USB host. And the reason, I think I showed it last week, but the reason to look into USB host was the really cool, as I said earlier, the RP2040 demo using PIO as USB host. So that gets us to the point where we have two USBs in one chip, and that's really ideal for us because we can continue to do the CircuitPython workflow over CircuitPy, but then also doing USB host at the same time. So having two is great. There is one other option for that. This brings so many potential project ideas. So I was working on the PIO stuff in CircuitPython. I got a little bit in the weeds with that because a lot of it's in tiny USB. And so I've actually tried to hand this off to TAC. I haven't heard any updates from TAC yet about it. So TAC is the maintainer of tiny USB and is creator and maintainer of tiny USB and is actually paid by Adafruit as well to work on tiny USB. So if you want to support TAC, you can do that by purchasing from Adafruit as well. Yeah, TAC does a great job. Oh, there's an ESP USB soft host as well. That's interesting. For low speed only. Yeah, so the PIO demo is able to do full speed as well, which is interesting. Pierre says, my S3s from Unexpected Maker are traveling right now. Still no traveling for me. Terrace says, the RP2040 is something I really want to try using one day. The RP2040 and particularly the PIO is amazing. They're really inexpensive to try, so I would totally take a look at that. So Gamma Games says, will there be a helper library to make the dual USB easier to work with? So there's already on tiny USB, or not on tiny USB. The PIO thing is this. Look at my browser history. The Pico PIO USB repository. So if you want to start and play around with that, you can take a look there. I'll drop that in the chat. And yeah, I love tiny USB too. There was a point where CircuitPython, I kind of said look, we're just going to switch to tiny USB for all of our USB stuff because I was fixing bugs in the Atmel provided USB stack, and I was like, but it has a license that says you can only use it on Atmel stuff. I was like, why am I using this vendor provided stack that has bugs in it where I can see the code and I can fix it, but I can't then have fixed it for all of the places that we need to use USB. So I thought that was kind of silly. So TAC had already written a lot of tiny USB, and I kind of took a look at it, and I don't like to tightly couple CircuitPython to a lot of things, but that was one case where it was just I don't need 5 USB stacks because all of this, most of the stuff that it does is all class level, which is USB HID, USB mass storage, USB MIDI, are all things that are generic and defined kind of outside of individual vendors. So it doesn't make any sense to have multiple implementations of those things. So I chose to just bite the bullet and switch all of our USB stacks over to tiny USB, which I think was basically, that we had done Atmel and then we were about to do Nordic, I think. And it was instead of having two different, like a Nordic stack and an Atmel stack, we would just have tiny USB. Paul's also waiting for the S3s. So yeah, so I got this demo going, and I was trying to like start to figure out how to fit it into tiny USB. And I had mentioned it to Tack, and he sounded very interested in working on it. So I initially said, no, I'm working on it. And then I went, what could I do if Tack was doing that part? And so my focus is shifted from that super low level, like PIO, low level of USB host, to the kind of the other end, which is once we have USB hosts, what does it look like in CircuitPython to actually use it? So that was kind of what I was thinking I'd talk about today, is like how I'm thinking about exposing USB host into CircuitPython. And I should say that we actually do have some boards, some microcontrollers that have two USBs on them already, where I can get it working. I don't need to wait for the RP2040 USB host stuff to be able to actually add the host APIs and things. Yeah, the Python API side. So that's what I'm thinking about. And what I've got is, I'll just unplug it. This giant dev board that I've complained about before, and I continue to think it's kind of terrible. But this dev board here is the i.MX 1060, i.MX RT 1060, and it's got these two USB plugs right here because it has two USB-otg peripherals in it. And they can do, Tara says, I'm a Python programmer, so this is right up my alley. Awesome. Yeah. Yeah, so this is an i.MX RT 1060, and it's on the Teensy 4s. So Teensy 4 and the i.MX 1050 and 1060 have, yeah, this board is gigantic. It's gigantic, and the thing that bothers me the most is that there are no labels. Like, there's a ton of labels, and they're all the like schematic labels. So you want to look at these two USB plugs. They're not labeled USB 1, USB 2. They're labeled like J something, right? Like J9 and 10. And the buttons are labeled switch 3 and switch 2. They don't tell you which one's reset or boot or whatever. So yeah, not a huge fan of these boards. But then again, cheap dev boards, which have like all this stuff on them, are kind of awesome anyway. Especially these i.MX RTs. I was very excited about these when they first came out, because this i.MX RT, the 1060 is clocked at like 500 megahertz. Like, it's very quick and has like a megabyte of RAM. So we were planning on getting into these i.MX RTs more. But they've actually been really hard to come by, so I'm not sure they're available yet, but at some point they'll be more available. And in the meantime, this is a great way for me to do the USB host stuff. So if you do want to, they could have labeled them press and see what happens. Yeah, it's just kind of outrageous. So but yeah, I can use this to get it working. And then, correct, this is the EVK. There's a EVK-B now, which might be better. I don't know what the difference is, but I picked it up pretty early because I was following this chip family a lot. But the Teensies are really pretty affordable, the Teensy 4s. They don't have two USB plugs, but it's not that hard to just plug it in anyway. Yeah, and Tara says, I have a Teensy with an i.MX RT 1062. So you should be able to run CircuitPython on that. It's not gotten a lot of love, but I think it still works. And in fact, that's one of my next steps, is to get it going on this board again. B for better. Yeah, probably. So yeah, this is my EVK 1060, and these are cool chips. They're super fast, and this one has 2 USBs with embedded PHYs. So PHYs are the things that actually do the like changing of the signals, the physical interfaces, I guess is what PHY is, and they're high speed as well. So this was the first chip family we found with high speed USB, which is 480 megabits per second instead of 12. So these are going to be really cool chips when we can actually buy them. Yep, and Toddbot points out that Teensy already has a USB host library that works on Teensy's. So if it doesn't work on CircuitPython, you can always try it on Arduino with Teensy Duino. And Deshipu's pointing out, at least the ones of us with the compulsive microcontroller. Oh, we all do deep in our drawers. At least the ones of us with compulsive microcontroller acquisition disorder. Can I let you in on a secret? Somebody nerd sniped me. So nerd sniping is a term that I use for bringing up a topic that is of great interest to somebody, even when it's not the thing that they should be paying attention to or working on. I guess you could also think of it as like, ooh, shiny and like distracting. So I got nerd sniped in the last week, I think it was, and I finally gave into that. So a few weeks ago, Lady Ada had pinged me and said, hey, what do you know about FPGAs? Because she's starting to think about like longer term projects and stuff. And with the long lead times for chips, she was thinking about whether like some FPGAs were things that she could get. So she nerd sniped me on FPGA stuff. And then kind of, I don't think it went anywhere. Like, it was still kind of uncertain what we wanted to do. But in the last week or two, somebody has dropped into Discord and said, hey, I know that CircuitPython runs on the Cortex A53 and the A72, which are the Raspberry Pis. I'd like to get it running on a Cortex A9. And this A9 happens to be right next to an FPGA. So Xilinx has these chips called the Zincs, and they're kind of half microprocessor and half FPGA, where they have dual core Cortex A9s, and then they have dual core Cortex A9s with like 512 megabytes of external RAM. So they're actually designed to run Linux. And then that's all connected into like an FPGA as well. But it also has hard USB. So it has USB. Oh, it has a USB peripheral. Let me just pull it up. So the Zinc 7000. And yeah. So the regular 7000 is the thing that I got nerd sniped with. So here's what you can see. It's got like dual A9s. It's got a huge cache. Lovely A72 says the RP2040's native USB can only do slave. So no, it can do device and host, but host we want to be able to do both at the same time, so you can still have the CircuitPy example. WebBSK says nerd sniped. Yeah, nerd sniped is a term I used for being distracted by cool tech, I guess. And in this case, because we're talking hardware, it can cost money as well. And Wuha says 11 says it sounds like mining rig boards on AliExpress. True, because I think FPGAs are used in mining stuff as well for as an alternative to like GPU stuff. And Deshipu says it was nice to know you. yeah, so the thing that got me was if I ignore this bottom part of this thing, it's basically just another microcontroller or whatever. Ari Yang says I have a Xilinx Core Z7 I can help with. So, yeah, so there's 2 cores. It can talk to the programmable logic. Slinky Tangle says Vivado if you love endless frustration. So the other thing I looked into, though, is that the open tooling has pretty good Xilinx 7 series support. So I was looking at github.com, SymbiFlow Project X-Ray. So SymbiFlow Project X-Ray is documenting the Xilinx 7 series bit stream format. So the open tools should actually work with this. And if you look in the database, they actually have Zinc 7s in here for the 7010s and the 7020s. So not all the different variations, but the variation that I ended up ordering off DigiKey 2 hours ago because I gave in. It is supported by the open tools. So that may not mean fully open or fully supported, but I did actually find also, where did I find it? I don't remember where it was, but there's also some like automated testing infrastructure for the open tool chains that they're using the Zinc series to do. So yeah, so I got nerd sniped by the ability to do FPGAs but not needing to worry about the CPU cores, assuming that I add support for the Cortex A9, which I don't actually expect to be that difficult. The Kaizitamilos 93 says, how does the Intel adoption of Risc-V affect the FPGA progression? It's a good question. I think more open FPGA support would be awesome. I don't know exactly what all that means. I think it's cool that Intel's adopting Risc-V, and they're definitely trying to pivot Intel, I think, a bit to more like, we'll just make chips for everyone, which is good too. And if you haven't followed it, the stuff that Mithro is doing, Tim Ansel with Google, and the free ASIC design stuff is really cool. If you haven't seen this, you can make your own silicon. Like you can design your own the Open Shuttle program. So this is fabless is a company that's to some degree the Oshpark of integrated circuitry. But Google is sponsoring these programs where you can design a chip and they'll manufacture it for you and send it. We always called it geek trapping. Interesting. So they give you full documentation on the 130 nanometer process, and you have to just post your designs to GitHub, and then you can get it actually manufactured if it's openly licensed and stuff. So that's just, it's really cool. There's some really cool videos on, like, they just got the first one back there. Because it takes so long, they're like starting things as they go along before they even get everything back. But yeah, this stuff is really neat, and they're working on doing more technologies and stuff. So I would hope Intel would like make available some of their older technologies, which would be really cool. Which is another reason that I was like, oh, I think it might be time. maybe during my paternity leave, when it would be like, oh, I'm just gonna play around with this FPGA stuff. Lamore doesn't want me doing it. Lady Ada doesn't want me. She nixed this, but I gave in. So the reason I gave in, it's an open source supported to FPGA in this. it's dual core A9, so it shouldn't be that hard for me to get it going because I've kind of gotten over a lot of the hump of learning the Cortex A series stuff. And then what I also saw here is that this has, hey Rich, there are 2 hard USB IP blocks. And I did some research and they're called, what's the name? I forget what the name is, but I was just looking in TinyUSB doing this host stuff. And I was looking at the i.MX, the board that I was showing you before I was talking about how I got distracted. And the i.MX has the same USB peripherals as this Zinc does, as the Zinc chip does. So I couldn't help myself. I could not help myself. It's in TinyUSB, or no, I was looking in, if you look at TinyUSB board support, i.MX RT, and then family.make, what you'll see is it uses the source from Chip Idea. Rich says, I'm really interested in FPGAs, but haven't had time to dive in yet. So yeah, Chip Idea is the name of the USB core. Sorry, let me... There was by follower spam on Twitch that I had to ban somebody for. So Chip Idea, and this is the same USB chipset that is on this Zinc with the Cortex A9. So I gave in. I just ordered it. It's probably not. It's probably going to just sit in my giant box and at the bottom of my drawer like Deshipu's talking about, but I just couldn't help myself. I just couldn't help myself because what I'm picturing in my mind is that you can have CircuitPython running on it and you can say, all right, put this on the FPGA and then interface with it, like all without having to like restart or worry about any of that. So I'm pretty interested in seeing how that works. Yeah, I wish PC companies would open up all their older components to allow hardware changes without major hacks and overhauls. I agree with you. That's the beauty of open source hardware like Adafruit does. And George points out that AMD's acquisition of Xilinx, which they completed this week, I think, may have some effect on FPGAs as well. Yep, I think that'll be interesting. And Wuha linked to a Zinc board. One thing I would caution you if you're interested in this is unlike the i.MX RT, the Zinc does not have the USB PHY on board. So it has to have an external one, and from what I was looking at the dev boards for it, not all of them support USB device. They usually support USB host, but they don't always do USB device. So I actually bought not the cheapest one because I wanted one that could do OTG, so it could do both. We all have a lot of dev boards that looked super useful until the next one. And it's kind of my job to have them. Like I've got basically the whole series of the i.MX RTs. Like it's handy to have them, especially if it's like one day you're like, oh, I want to add support for this, and you don't want to have to wait for shipping and stuff. So, all right, well, that was a huge detour in how Scott gets distracted by shiny FPGA chips that are also Cortex A level stuff, but that's not really going to be, that shouldn't be my job because I know it's too high cost, I think, really for did he share what version I bought? I can show you what I got. Let's do a quick DigiKey detour. So if we want to find that, it's under, well, we can just like Zinc 7010. It's $200. The cheapest ones I found were not modules. I think it is the evaluation boards. But let's do series Zinc 7000 in stock. Pierre says, you are one of the few that can actually justify their collection. Slinky Tangle says, I worked with the Micro Z and the Red Pitaya. There are a lot more other expensive eval kits. Oh, Zarlin says, thanks for last week's tips. I have Circuitvisor working on the Pi 0 2W and the S3. Nice. Yeah, so if you just look here, the Zybo is what I ended up picking up. And in the image, if you can see, it's labeled USB-otg. And I did my digging and looked it up. If you look at the, well, sort by price, it is still one of the cheaper Zincs. So there's this pink board, which is funny because it's like meant to be Python and the Zinc, and it's only got USB host, I think. Note that they have HDMI as well, which is cool. And of course they have the Arduino, the Arduino footprint. But yeah, so I picked up this Zybo one that I can link you to. Of course, I make no promises that anything ever happens to it, so be aware of that. I've got one of these on my bin. I'm about to dive in. Digilent has a huge selection of PMOD adapters. Yeah, and I have a collection of FPGA boards. Like, let me be real, and I don't use them. But for some reason, this is interesting to me because I know I can do the hard IP sides of things. Like the folks that did there's an EOS S3, which is like an open thing, and they did like an FPGA version, or they did a Feather format of their like hybrid microcontroller and FPGA, but they don't have USB outside of the FPGA. So if you wanted USB support, you would fill up the FPGA with USB and you wouldn't be able to do much else. So this is this is what I just picked up. I don't have it yet. This Zybo Z10. But yeah, I finally gave in to that. And I justified the money because luckily I have a bunch of GitHub sponsors and they give me some extra spending cash for my business. So I was like, I'll just consider this like something I use that money for. Because I know Lady Ada doesn't want me working on it, even though here I am talking about it. But the USB side, I should be able to get tiny USB going on it with hopefully not too much trouble. Oh, interesting. Tara says, I bought my first FPGA recently, a Tang Nano 4K dev board that has a GOWIN blah, 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 that has a Cortex M3 embedded. Haven't worked out the tooling yet. Let's take a look at that. Do you think DigiKey has it? Nano 4K. I don't think the GOWIN ones are supported by the open tool chain. Tang Nano 4K. Dev kit details. It's got a USB connector, but there's very clearly an adapter next to it. $4,000 or so LUTs. I was thinking, wouldn't it be cool, and I don't know if this is possible, but with the Zinc, whether we could put a Risc-V core in it and then have it talk to the USB directly so that we could like switch between the two. Okay, so it's got the M3, but I don't see any mention of USB. I believe I believe it that the open tooling, like cost is such a barrier. Yeah, $18 dev board versus the $200 I just spent on that. But USB, yeah, I'm such a USB person. Technology says, I'm hoping I can use the ST dualsynopsys-usb-otg with CircuitPython host and device. It's also a new dad thing. I've been doing it a while. What is this? Until you realize that HDMI. Yeah, large, full HDMI. Forge FPGA. Oh yeah, this feels more like the mock X02s are really interesting to me. The mock XOs from Lattice. So there's kind of two ways you can treat FPGAs. There's one that is like, I want to just treat it as like a little bit of extra circuitry next to my main thing as like glue logic. Or there's I want to create my own system on a chip virtually on an FPGA. And those are like two very dramatic different uses for it. Whereas like one needs a lot of resources and the other one doesn't. Yeah, so if you want to know what has support for host in TinyUSB, if you want to help me with this would be awesome. But if you look in examples and host, there's this HID controller and there's this only.txt, which lists the boards that the examples actually run on. So CircuitPython doesn't have any of this LPC support. We do have the i.MX RT support, and you'll see this host example actually works on the RP2040 as well. The GOWIN FPGA in the board has a USB PHY. Interesting. Did I close that tab? What was the part number? Welcome to Deep Dives, where we don't always talk about what I advertise as what we're going to talk about. Hi, Tara. Yeah, can we find the... Oh, here's the... But that's like an announcement. Is there a... Oh, this is a handy reference, I think. Open source tool chains. Oh yeah, here's some like no-name boards. Interesting. Oh man, the pink has a 7020 on it. And OTG host. That's a weird way to say it. And it's dead. This looks like a handy reference. This is what I picked up, but I picked up the cheaper version of the two. JTAG USB. JTAG USB sounds different. Pretty amazing that a $1 MCU can be a USB host. Oh, DigiKey knows I'm talking about them because they just shipped my order. I tend to, my interests like kind of cycle. I get really into some things and then I kind of move away and do something else, but I do actually go back to things. Does Adafruit have any interest in making more networking gear? Probably not hardcore networking stuff, but we're making more and more devices that are like network connected. But I don't think we'd ever make like a router or anything. yeah, we should maybe talk about USB. USB host. So what is USB host? So we've talked a lot about USB device. So USB device is you connected to something else. And where do I want to start? So what you can say is, hey, I'm a keyboard, or hey, I'm a mouse. Like that's the basics of USB, of a USB device. And then it can get more complicated. You can say, and this is what CircuitPython does, is you can say, hey, I'm a mouse and I'm a keyboard. And that's what's known as like a composite device. I'd like to see a coax to SFP+. You could always email support with suggestions, but I doubt that we're going to do something like that. The USB host, the best USB to have around for your party. Today's Foxes in Love comic was precisely about this. Yeah. So USB devices say, hey, I'm just going to be a keyboard, and that's that. Whereas, and the opposite side of it being a USB host is like, I want a keyboard to plug into me, or I want some other USB device to be plugged into me. And the job of the USB host is to manage that device and any other devices that are connected to it. Because not only can you have a single device connected to you as a host, but you can potentially actually have like you can have a hub connected to you and then multiple devices connected to you after that. So imagine that you have like a hub, and then you plug a USB keyboard and a USB mouse into it. And what the USB host needs to manage is like, what devices are there, and who do I need to talk to, sort of stuff. So, and yeah, and all of the communications on USB are host initiated. So there's like a start a frame packet that goes out every millisecond for USB 2, USB full speed and low speed. And then there be packets that say like, hey, you device here, like tell me, like has anything been pressed? I'm not describing that well. Let me show you, is that where I want to start? Maybe not. Maybe that's not where I want to start. So what I've been thinking about is, what will the API be that we present to CircuitPython user code? And there's a couple things that I'm considering too, because I do want USB to be able to run outside of the VM, USB host to run outside of the VM, because I do have this world where a board, oh yeah, Ben Eater's video is great. Yeah, let me plug that too. I actually watched that on Friday. Let me make sure you don't see all my YouTube stuff. Or Adafruits. Yeah, yeah, Ben Eater did like a whole series. Crisada says, I forgot why I was subscribed, but this seems quite interesting. I'm glad you find it interesting. If you have questions, I'm happy to wander away. If I want to plug in a keyboard, would I receive hit events and have to deal with them? Yeah, so let's talk about that. And I think, yeah, let's talk about what that means. So I think I've got, so this is the S3. So let's just take a look at this. Host mode features 8 channels, pipes. A control pipe consists of 2 channels in and out, as in and out transactions must be handled separately. Only control transfer type is supported. So there's this idea of, in host terms, it's known as pipes. but in device terms, they're endpoints. So if we're using a keyboard as an example, which I know Pierre is interested in, who makes keyboards, you would have like an endpoint that is an interrupt endpoint that is where your reports about what keys are pressed go. And to call them interrupt is not... Interrupt is super overloaded for people, but the idea with interrupts on USB is that it gets pulled every so often by the host. So the host will say like, hey, how fitting HID management. Yeah. Yeah, so yeah, it's everything on USB is actually pulled, but interrupts are kind of have a guarantee about how frequently they'll be pulled. Whereas other types of endpoints don't necessarily happen. And Pierre says message queue perhaps. Uh-huh. Yeah. Yep, you're going the right direction. So let's see what, in terms of the hardware on the S3, each of the other 7 channels is dynamically configurable to be in or out. So in is into the host and out is out from the host. And then there's, this has 3 types, but I think control is a 4th type. Bulk, isochronous, and interrupts. And so I think that, so bulk is typically used by mass storage. So when we're talking about reading and writing bytes on mass storage, that's done through a bulk and 2 bulk endpoints. Isochronous is, what is it? It means like consistent in time or something, right? So it's like, it's for audio generally. And then interrupt transfer types are like your HID stuff. It's a common pattern of impersonating hardware interrupt with pulling a reliable frequency. Yeah, that makes sense. Terabyte says, would it be smart to implement Python classes that represent HID devices at the high level? Yes. So I think that's what where my brain is going, except for the fact that I do want to be able to do keyboards natively so that I can do it outside of the Python VM. So let me see if this works. I have the other way I thought about talking about this, and maybe I should talk a little bit more about this, but I also have the USB 2.0. The 2.0 spec here, and it might have some nice diagrams as well. So here's bus topology. So there's this root hub, and then you can have like multiple tiers of hubs and what they call functions, which I've been calling devices. So this limits like how many different devices you can have on the whole bus. There would be the need for low-level API and a CircuitPython host libraries. Yes, so that's where I'm thinking. There's only one host in any USB system, and there's a lot of devices. Here's the electrical signaling, mechanical, bus protocol, robustness. So you have to do attachment and detachment stuff. Control, bulk, interrupt, isochronous are all things that we've talked about too. So allocating USB bandwidth. So the host has to decide like in a given frame, which frames for low speed and full speed are a millisecond long. How are you going to talk to all the different devices in that period? Folknology says, are you going to base it on tiny USB abstraction or use mixed USB abstractions underneath? So it's all going to be on top of tiny USB. So I might actually have to change some of the tiny USB stuff. We'll see. Terabyte says, one of my projects is to develop a hardware control panel for Kerbal Space Program, and I want to plug it in via USB. And I've been looking at implementing it as generic HID device, so no drivers will be needed on the computer end. Yeah, so Terabyte, that for for acting as an HID device, CircuitPython does it really well. And you can do that already. You should be able to do that already with CircuitPython. So I'd recommend looking into it. Yeah, so CircuitPython's been really, really successful because of USB device support already, right? Like we have a lot of people making keyboards. My keyboard right now is running CircuitPython. And there's some great tutorials on that. In particular, if you do learn.adafruit.com and do custom USB, you can see that there's like, here's mechanical keyboard, keypad. But the one that I'm thinking of is this one, because this one has other HID device. So consumer control, advanced topics like custom HID devices, and boot and mouse support. And I thought there was gamepad too, but gamepad might be somewhere else. But I link a lot of people to this as well. Hi, Kevin. Is N-key rollover covered here? The Ben Eater actually has a nice tutorial on that. So you could do a custom HID device to give you N-key rollover if you wanted. Oh, and this is actually a gamepad example here. It's just not titled that. So yeah, for acting as a USB device, we have that really well. And so we're kind of doing, and we already have USB HID, USB CDC, and USB MIDI modules in CircuitPython for doing those native, but that's acting as those things, not receiving them. Beata says, that's what I miss about FireWire, having multiple hosts on the same bus. Oh, I didn't know you could do that with FireWire. One thing I'll need is sending back data back to the control panel for displaying. We also support, CircuitPython supports CDC, so I'd probably go that route. Although I was looking at the keyboard configurators and they use HID raw, so I'd love to do HID raw at some point as well. That would be cool too. I'd love to be able to, like, there's kind of a semi-standard for configuring keyboards over HID raw. And so I thought it would be cool to add that support to CircuitPython so that you could use those tools to customize your keyboards. So many different things to do. So many things to do. Okay, so yeah, this is all device stuff, and we've been doing it a while, and it works pretty well. So the question is like, on the flip side, how does our like USB worldview change with host instead of device? Yeah, that's a good point. JP says this is not a great tutorial to start with for HID. Yeah, this is more the advanced stuff. Yeah, so here's the list of existing host examples for TinyUSB. So if you're on a platform like somebody was talking about ST, this is the place to start if the platform doesn't support host. So what I'll do is I'm thinking about this high-level API for USB host and CircuitPython, but it will be connected into the USB host APIs of TinyUSB. And so for every platform that TinyUSB supports, we should be able to just turn it on in CircuitPython, have it be the same, have it be consistent, and do that. So what is the CircuitPython level API going to be? And then can I implement it and build it on top of TinyUSB? So I got that HID controller example running on this board. That's what I did earlier. And so now my next step is to build CircuitPython and get it loaded for this board, which I'll probably just do next week. But I started working out what the API would be, but that's kind of the brainstorming I've been doing. So oh, you're blowing my mind about FireWire. It sounds a little bit like PCIe, I think, can do stuff like that. So talking about hubs and then functions. Compound device appears to the host as a hub with one or more non-removable devices. But yeah, I think function is basically like the equivalent of what I think of as device. So they have these like logical communication flows. Yeah. This stuff gets tricky. Yeah, so this is where they start talking about pipes. And they say a pipe bundle to an interface. And I think there is a way for devices to have multiple interfaces that you switch between, but I don't know how common it is in practice. Good use cases for USB besides keyboards, smart speakers, and MIDI. Well, serial has its origins in modems. I know some people do like network connectivity over USB. But you can, like, a lot of people just want HID, which is human interface devices. And then, like, there's this synth crowd that wants MIDI. Like, it's okay if it's a few use cases, if everybody uses those. Tara says, FireWire was basically PCI, if I recall. They could get access to host memory even, which could open some interesting attack routes on old devices. Yeah, I've never looked into FireWire. I had it briefly when it was like a thing on video cameras. My computer age involved some FireWire, but not a lot. So I think that, yeah, oh, this is a good example. So this is kind of what I've been thinking. So there's this host side, there's client software, and there's buffers. So I think Pierre got to this before earlier, is that a lot of what we're going to be doing is just buffering data in and out. And then they have these pipes, which in my mind, like, they end up at endpoints, but like I think I'll just call them endpoints, because we are talking more in a world of where, like, we want to share the USB world. We want to, like, abstract away the host and device stuff a bit more. Yeah, so let me try. I have the GIMP open, and I actually have a tablet, a drawing tablet here. So let me just go a little crazy and see if I can't. I just set it up. But we can see if I can channel my, like, I think Robert Baruch's videos like to do this a lot. So let's see. Let's do, I'm still not used to this, but I'm going to make it a little smaller. So at the top level, we're talking USB host. So that's the first, like, the module level thing. I actually bought this a few weeks ago and I hadn't set it up, so I plugged it in and it just worked, so I was pretty happy. So I was thinking about this. Originally, I was just going to do .devices as, like, here's all the devices that are on the port. But I don't think I want to do that, because thinking more about it, I think you know, it's pretty standard in CircuitPython to have, like, a constructor. Oh, I don't know what I did there. But I think we want it to take like D plus and D minus, which are the two USB pins. And then I think there might be, you know, like we talked about VBUS a little bit. So maybe we want like keyword args for like other pins. So I think we do want like a high level port object. And on boards that have it like baked in, they can just instantiate this, and then you could have like a board dot USB. I just got this. I don't know why it might be confused by my hand. USB host, for example. What is it? It's on my lap, then maybe that's my problem. Oh, and of course I meant to capitalize that. Oh, I didn't notice, David. We're watching me use my new writing tablet thing. Okay, so I think port would have like a dot devices. Devices. And this would be like a tuple of device. And a corollary that I'm thinking of is like the BLEIO dot connections. I don't know what I'm doing so that it's doing that. Like very similar style. Ugh. Pen and paper under the top-down camera works best. Yeah. That would make sense too. Except I only have 2 more streams after this, so at this point I'm like, I'm not gonna change my setup at all. Yeah, I guess it could work, but I don't have the hover cam set up. So that's kind of like the corollary that I'm thinking of. So the other class that we would have, or one other class we would have here, is a device. Why is it? Oh, am I bumping the... There is a button on here that I'm not aware of. So these you wouldn't construct these devices. You would get you would get them from the port object, and they would automatically create them for you. So internally, they would know like device number, dev number. Let's do the number sign. So that is like the internal reference number that's used on the USB port. But then you'd also be able to do like d.vendor ID, vendor ID, dot product ID. And these are like your 2 super coarse, like, yeah, I'll get better at it too. USB to do automation stuff. Ooh, that is one thing I thought about. So if we could do USB host and do mass storage CDC, we'd be able to automatically update another CircuitPython board and verify that it works. So I think this could actually be really useful for automated CircuitPython testing. Okay, so where am I? So other things that we definitely want the descriptor. And this is the thing that is tells you a lot more information about what the device can actually do. And then one thing I was thinking about is there's a command in USB that is get string descriptor. So in the descriptor itself, there may be things that say, hey, I have a string name for this, and then you have to look up the ID. So I'm considering having like a get string descriptor function call where you'd give it like the number of the string descriptor that you care about. but I'm not sure that that's the best approach, because generally I like it to be better documented, but this is kind of like more of a free-form thing. Kevin says, when you said you only have 2 more streams, are you leaving Adafruit or something? I'm not leaving Adafruit. I am going to be on paternity leave because I am going to have a child at some point soon. Well, the kid's due date is the end of next month, so it's not like I'm overdue. But yeah, I'm going to be taking 18 weeks off total this year for learning how to parent a small child. Get string descriptor seems very Pythonic. I generally don't like getters, but I think in this case, because I think at this level of the API, one thing I want to avoid is I want to avoid being too device type specific. I actually want to be pretty vague. Yeah, import parenting. I want it to be pretty generic at this level. So this is the first level that I think you kind of need as a baseline minimum to do USB host. And then, like Pierre was talking about earlier, this is the level that we can build Python libraries on top of. For example, TinyUSB has a DualShock 4, which is a USB controller example, right? Like, they have the, like, there's no reason for CircuitPython to have DualShock 4 support built in. And even just supporting keyboards generically could be really tough. Kevin's relieved. Oh yeah. Thank you. Yeah, I'm excited. I'm ready for some time off. I'm ready to have to do some parenting, some diaper changes. And yeah, YouTube has machine-generated subtitles. We do have a little bit of a delay, but the delay is so that the subtitling stuff can happen. Oh yeah, and the Luna that David points out is actually another FPGA product. Okay, so device, and then vendor ID, product ID, descriptor, get string descriptor. I think that's largely what you need to figure out. Okay, what am I connected to and what can it do? And then in this descriptor here, which I don't really want to have native parsing stuff for. I want Python level parsing. The other thing it's going to tell you is it's going to tell you the endpoints that it has and what they can do. So I think that maybe we want like a, do we want like a get endpoint, get endpoint? Or is it like is it more like a separate, well, this would take a number as well. And maybe does it have to tell us? What about get serial number? Yeah, we could have serial number. So that would be up here. So the next step to figuring this out is I like to actually write the docs. If you've ever looked in CircuitPython's code base, you'll see there's a shared bindings. And shared bindings is where we do the conversion from like Python objects and functions into C. And that's where we like to put the docs in line. So I actually like to write those up first. And then what I do is I kind of work from there. And then from there, I'll implement it kind of all the way down. And Pierre says, would you need get endpoint or get message from queue? Yeah, so what I would do is, and maybe let me open a new file, which I could just do it. So the other piece of this puzzle is, so this is USB host. Well, this is a question. Continued. I'm picturing like an endpoint. In Right, so this is the thing that has the buffer of packets in. And then there's also endpoint out. And that's generally one or the other. Buffer outgoing. We may not actually need to buffer outgoing, but that could be there. And then I think the only one that's weird, so control can do, is actually bidirectional. So I think we want two different ones because I want it to be, when you're working with the object, I want it to be clear. So this would have like a device and an endpoint number associated with it. And this would have a device and an endpoint number associated with it as well. I don't know exactly how you would get it from the device. I'm not sure you would just construct it. Like, it would make sense. HID has both in and out. I don't think that's on the same endpoint number though. So you would just have two objects. You would have one for one direction and one for the other direction. You don't need to have both. Like, I think that, yeah, I don't think they're both. Where was that other one? Where I work. Oh, folks are back. I don't know where that came from. I've been playing around the idea of USB devices for sensors and motors that could be used with either PC or Mindstorms. Elysis, I think, is what TAC uses. I use Beagle. I have a Beagle 480 now. That's pretty handy. Oh, there it is. Zarnland says, where I work, we tweak the USB to handle 128 endpoints at once. I think the main thing is that like per endpoint you get different buffers. RP2040 Featherboard with Wi-Fi for 15 bucks. I'm all about, unless you need PIO on the RP2040, just buy an S3. Like, or an S2. Like the ESPs, if you want Wi-Fi, use an ESP. Only if you need PIO do you need the RP2040. Like, and some people have said they do, but generally I don't really like two controller solutions. Okay, so I think, so this is 5 classes, and these are basically going to mimic, like these are basically queues. So inspiration for what this API is like queue, but also like packet buffer from BLE.io is also an inspiration for what that'll be. And in fact, I haven't done it yet, but we should be able to do like HID host over BLE, and like we should be able to swap those in. So this is also going to be modeled after queue and packet buffer, although packets out rather than packets in. So I think that's kind of that's the lowest level. That's the lowest level of it all. I was considering, and I'm not sure what I want to do, but I was considering doing like endpoint types. So USB host, like bulk. But I think we can just split by direction. I don't think we need like host interrupt. Like, I don't think we need separate sets of things for these things. Oh, interesting. Controlling 32 ZC at once, which results in a lot of endpoints. Correct. HID host over BLE. Wait, my brain hurts. You mean connecting a BLE keyboard to a CircuitPython BLE board? Correct. Correct. So that's the similar case where it's going to be sending you reports of what keys are pressed, and you need to buffer them in so that you can see like what all the keys were pressed. And we don't currently do that. There's a bug on the BLE library, but I haven't actually gotten to it. But when we're thinking about this API, we should be able to build kind of the same thing on top of the two. And we've managed to do the HID device is pretty interchangeable between USB and BLE. So we've done a good job there. We just need to do it kind of the other direction of reading data in. So I think the thing that I've been thinking about there, and this is, I haven't talked about keyboards yet, but I've also been thinking about keyboards in general. So I think, and I've been thinking about how I would write keyboard software. So like there's existing examples of like QMK and KMK are kind of the classic examples, but I have a problem with this code because they say like they don't show you the loop, which is kind of my beef. And I was thinking more about like what a keyboard is doing. It's like a while true loop, right? And the first thing it does is it like gets all pressed keys. And this is a matter of like key number. And then you can translate that to from key number to like USB HID number, which is what BLE uses as well. But the problem, well, and that's what you would send over BLE or USB. But there's a third step that you need if you're wanting to actually show something, like in the terminal. You would do like USB, like HID to like ASCII, or what is it, like VT100 or UTF-8. So this is not only like characters, but also like cursor control. Like deleting characters. I'll be curious to see what y'all think of my let me scribble in GIMP stuff. But I thought this could be, I feel like I've kind of like struggled a bit showing my process for API design, because usually it's like me trying to like formulate sentences to type in comments. Whereas this lets me be a little briefer on screen, but also talk about what I'm thinking about. And so this process is interesting, right? Because what we're talking about for USB host is here, right? Like this is USB host. Or like USB host is one of the things that can do this. Same with BLE or key scanning can do this too. And then if we want to be able to do like this C64 CircuitPython, right, where it's all built in, like we need to do this whole process natively kind of outside of Python because we want it to run after that. This is the first time I've used this tablet, but I'm happy with it so far. My wife, we got a new couch and she wants to play around with it. always good stream when I'm texting on camera. Okay, so yeah, so this is kind of what in the back of my brain I'm thinking about too. Of not only that when I support USB host in CircuitPython, I also need this process here to get into basically. Oh, I didn't say this, but this is basically like the equivalent of like USB serial, right? Like this is the equivalent of what we are getting over the serial link from CircuitPython. So yeah, this is something that if we want to have that experience of just editing and using a keyboard to input into CircuitPython, this is the stuff that we need to do. And then also thinking about just mechanical keyboard software, there's this stuff too. And one of the tricky things is in here or in here, and maybe Pierre is talking about this too, is actually like, what is it? Key maps, key layouts. Like I don't actually use QWERTY. QWERT or Colmac. So like if I wanted to create a CircuitPython thing, I use Colmac. So I actually need to do this like extra mapping step in here as well so that I'd be able to actually type on it. So yeah, this is my process. My brain is thinking about what I want for the USB host interfaces. So let's just take a peek at there. And if folks have feedback on this, let me know. But basically what we'll have is we'll have a port class that you give it the pins that you want to use for the port. And for most microcontrollers, that'll be super limited, right? Because they don't usually connect a lot of different ones to it. But potentially when we do RP2040 PIO, that'll be pretty flexible. They'll need to be next to each other, but besides that, like generally that's going to be pretty constrained. And then for device, so on a port, you'd be able to see all the devices on it. You'd be able to have a device object with some basic information like serial number, vendor ID, product ID, and descriptor. And then you'd be able to kind of do these like manual get things based on the descriptor that you've understood. Like we're not going to do descriptor parsing in the core, except for keyboards, which will be separate and as part of a separate module. So we don't have to have all of it all at once. We need to like split it out into chunks. So we have port, we have device, and then we have endpoint in and out. And in and out can handle all the different types of endpoints. I don't think we actually need to care. Like tiny USB really is just transfer and transfer complete callback. But I do want in and out to be separate just so that the APIs are different. And so we might need to expose the control access too. We probably do. And it's weird because it's bidirectional on a single endpoint. I don't think we're going to do this, so I could just cross this off. And then, because I don't think there's a lot of code that's different between all of them. And then the highest level is like thinking about this keyboard process. So it's USB host will be 5 classes port, device, endpoint in, endpoint out, and control. And those will all be built on tiny USB, and that'll give you enough information to see what's connected to you. Oh, that's what we need. Device needs .connected, because just like in BLE land, you could plug a device in, start using it in CircuitPython, and then unplug it, and you have a problem. And Folknology says async USB host versions. So I think that generally this isn't async IO, but a lot of it will be asynchronous. Like we could get these things early and store them, or not. Like maybe we don't actually get the descriptor until you call it, and that's blocking. But generally the way that we'll do async is through these queue-like objects rather than proper async IO. A lot like packet buffer, where you just say like, is there another one? And maybe in the future we integrate that into async IO so that you can actually like sleep while it's happening, but that's complicated. So this gives me a sketch of what the API looks like. And then my next step, well, I'll sketch it all out and start filling it in. And then what I'll do is I'll do examples as well. So I'll do example code that is actually useful for testing. So my first example will be USB import USB host, well, here I'm writing it in the air. Let me just do one last one. So like if we're talking like the most basic example, it's going to be import USB host, and then P equals USB host port, and blah, blah, blah. And then I'm just going to do print p.devices. And maybe I'd do that in a loop. So that I could like watch how that changes as I plug in a device and unplug a device. And then maybe once that works, I do like a for d in p.devices. Maybe that's what I do instead. And then I could print like d.vendor ID. Right? Like that's the first product ID. Like that's my first, most basic, like that. In video game terminology, this is like the quote unquote vertical slice. Right, this is the proof of concept that goes from CircuitPython into C, into tiny USB, to the hardware and back. And then back. So yeah, that's the plan. Hopefully I didn't bore too many of you. I think I lost some viewers, but all right. Well, I think maybe I'll export these and just so that we can dump them in the notes doc as well. But I'll do that off stream, not with this, but with the mouse instead. Any final questions? We're just about out of time. Otherwise, and I'm hoping to have like this API laid out in a like draft PR for feedback as well. And it's getting hot in here. 77. But yeah, that was good. I've been thinking about that. What's the model of your Magic Tablet? I have a Wacom. I think the BLE version's only like $10 more. So this is that's the front, and it's the Intuos. Oh, it's still kind of small. Here, let's switch. This is the back. Can you read the model number? It's CTL6100WL. But yeah, I just set it up like right before the stream, and it's been working pretty well. So so far so good. Based on your writing, you should have been a doctor. I've got time. I'm still young. I could be a doctor. I'm not. Yeah. I type. I don't write. That's why I was talking while I was scribbling. All right, let me pull up my housekeeping. So thank you all again for joining me for this deep dive. It happens every week, Fridays at 2 p.m. Pacific. I'll only be doing it for another 2 weeks, and then I'll be on paternity leave. If you want to support me, please do that by going to adafruit.com and purchasing stuff there. If I distracted you and got you into DigiKey ordering, DigiKey's great and they support Adafruit too, so don't feel bad about that. You can purchase Adafruit stuff from DigiKey, and that also like benefits Adafruit. So don't feel bad for picking up Adafruit stuff from DigiKey as well. If you want to chat with me and a bunch of others, we're on the Adafruit Discord server, which is this middle box here. You can join it by going to adafru.it/discord, and that will be where we're hanging out. We're talking CircuitPython. CircuitPython dev channel's got updates about like all the stuff that's coming into CircuitPython, so it's the place to be for CircuitPython development. Next week's on Friday, and probably the week after that too. And yeah, all notes are available on GitHub. Thank you to David and Patrick for taking those notes and aggregating them together. That's github.com/adafruit/deep-dive-notes. And yeah, thanks to those two. Thank you all for hanging out. Welcome to the new folks, and we'll see you on Discord, and we'll see you on the deep dive next week. So I will pet both cats, which I don't usually do, and then get out of here. I always end the stream with petting cats, if you didn't realize that. And usually Vin's not in here, so we'll see what she does. Have a great weekend, everyone. Kitties. Can I pet you? Rough life. All right. Have a great weekend, everyone.